All right, so I've still got the question we weren't sure about. I was not sure about up on the board. So it was correct. It was fine as we left it. But let me explain why and prove why. That's the thing that I should have done if I had the time to prove that it actually is correct. So here's what it was. 3x, inequality of an absolute value of 3x minus 12. Absolute value is greater than 6, meaning that whatever that is, whatever that solves to be, from 0, it's all the numbers that are at least 6 away, and on either side, minus 6. But again, like I say, when I erased this that I wrote up on the board, that's not the graphed solution. That's just giving us an idea that we're talking about values that are greater than a certain number and less than a certain number once we've solved for x. Again, just before I erase that, that number is not 6 because we haven't solved for x yet. So let's solve for x. I'll delete that. All right. Then 3x minus 12 is going to be greater than 6. Also, though, 3x minus 12 should be all the numbers that are less than minus 6, and that is the way that we're supposed to do it. So let's solve for x with both of them. So x could be greater than 6, as it turns out, and that not the best example because we're back at 6 again. But over on the other side, we don't end up with 6. We end up with so x is going to be less than 2, actually, to satisfy this absolute value equation. So now we can graph it because we know what we're looking at. All values on the number line that are greater than 6 or less than 2 when they're plugged into this formula will be giving us numbers that are 6 away, either positive or negative, from the 0. So we graph this as the graphed answer. So where's our 0? Let's put our 0 here. There's 2, 4, 6. That should be enough. So we graph it. All x's that are greater than 6. And this is, like I said, this is what we had on the board. So just check your notes and add it if you didn't copy it off the board. So less than 2. Something like that, but not including 2 and not including 6. That's the answer. But like I said, what we should have done if we had had time is checked to make sure that it is correct. If it is correct, then let's test some numbers that should work and numbers that shouldn't work. Let's start with the left side of the graph. A number that will work is, for example, 1. And a number that won't work is, for example, 3, if we are correct. So let's try 1. It should work. And let's try 3. It should not work. All right, here it is, the absolute value back to the original equation. So the absolute value of 3 times 1 minus 12 should be greater than 6. 3 minus 12, absolute value greater than 6. 3 minus 12 is absolute value of minus 9, greater than 6. The absolute value of minus 9 is 9, and 9 is greater than 6. So we thought that 1 should work, and 1 does work. I think what I'll do with this is just shrink it for now. So it worked. We're happy. Now let's try it for something that shouldn't work, which is the 3. So the absolute value of 3 times 3 minus 12 greater than 6. The absolute value of 9 minus 12 greater than 6. 9 minus 12 is going to give us a minus 3. Is the absolute value of minus 3 greater than 6? 3 is not greater than 6. Right, there's our 3, and it should not work, and it does not work. So just for argument's sake and consistency, let's shrink that one. So in terms of the left side of the graph, it works. So let's try a couple of numbers on the right-hand side of the graph. Let's try 5 is a logical choice, and 7. So what am I going to do? I'm going to move all this to okay, here we go. And you don't have to do this on a question if you don't want to, but if you have time, you can, and you may be asked to, in fact. Here we go. So we're going to try to solve for 7, which should work. Try 7. And try 5. That says it should not work. All right, 7. The absolute value of 3 times 7 minus 12 should be greater than 6. Absolute value, 21 minus 12 should be greater than 6. The absolute value of 9 should be greater than 6. 9 is greater than 6. And then the one that should not work, we're saying is 5. So the absolute value of 3 times 5 is 12, greater than 6. The absolute value of 15 minus 12, greater than 6. The absolute value of 3 greater than 6. Is 3 greater than 6? No, it's not. And that's what we expected. So we've done 2 checks on either side of our lower limit, 2 checks on either side of our upper limit, and it worked. So back to the solution, the graph solution, just to end here, graph solution is that, and we represent it via the solution with those 2. And it would be and, by the way. It wouldn't be just or. It would be all values greater than 6 and less than 2.